The new topic now we'll study is counters. Counters. Counter is a sequential circuit which is used for counting the number of clock pulses. Counters are used in various applications like frequency divider, waveform generators, measurement and range of frequency measurement. So let's start with what counter is. Counter is a sequential circuit, that is, it counts in sequence, either in the up sequence, that is from 0, 1, 2, 3, or down sequence, that is sequential circuit counts from 0, 1, 2, so on, or example 9, 8, 7, so on, are used in frequency divider and waveform generators. Now, state of counter. What is the state of counter? Let's say this is a very important concept. State of counter. The number of possible outputs available from the counter is known as state of counter. That is, the number of possible outputs available from a counter is known as a state. Now let us say, for example, if there are n flip-flops, you can say for n number of flip-flops, maximum of 2 raised to n states are available. Example, if n is 3, that is, let us say if n is 3, therefore max state, we can say, therefore max state is 2 raised to n is 2 raised to 3 is equal to 8 is the max state. So we write down as formula, let m be number of states and n is number of flip-flop. So number of states m is given by the formula 2 raised to n, or n, that is number of flip-flops, is equal to log to the base 2 of m. A very important concept to find out the number of flip-flops. Or n is also given as 3.3 to the log to the base 10 of m. Now, mod of a counter. Next topic, modulus of a counter, we say in short form as mod, or we can also say in short form as mod of a counter. Mod of a counter is defined as number of distinct output available from a counter. Now, what the state of counter was? The number of possible outputs available from the counter. Now, when the modulus of a counter is number of distinct output available from the counter. So we often get confused between the modulus and the state of a counter. So to avoid the confusion, let us study in detail what the modulus of a counter is and how the mod of a counter can be found out. So the modulus of a counter is very much related to the number of clock pulses. That is, the number of distinct output is related to the number of clock pulses. So we can also find the number of clock pulses here, like the shift registers we have found out. We can see, or we can check the number of clock pulses to required to find out the mod of the counter. So how it can be found out? Or the other definition of mod is also the number of clock pulses required to get its initial condition, is also called as a modulus of a counter. So let's see from the definition the input frequency and how we can check out. Let's say this is a mod M counter, okay. If this is the input frequency here, therefore the output frequency here, the output frequency for a mod M counter is found out by a simple formula. It is given by output frequency for mod M counter is equal to input frequency by M, modulus of a counter, which is given this. Let's say this is mod M. We understand this frequency calculation for mod M counter by a very simple example. Let us say this is a question, mod M of a counter, this is mod N counter, and this is, let's say, mod O counter, okay. What will be the total output frequency? So we'll go step by step. So first, the output frequency for this mod M count, or let us say input frequency is F. So the output frequency for this mod M counter will be F by M. This F by M acts as a input frequency to N. So therefore the output frequency to mod N counter will be F by M N. Now this output frequency of mod N counter acts as an input to mod O counter. Therefore the output frequency for mod O counter here will be F by M N O. That is, the more the number of stages, the more the output frequency gets divided. So therefore we can also say from this above example that the above counter is MNO counter, where the output frequency is F by MNO. Therefore we can say is F by MNO or MNO counter. Now let us see classification of counters. What are the types of counter and how they can be classified? First type of counter is asynchronous counter. Asynchronous counter, also called as ripple counter. We'll study in detail what this asynchronous and what this ripple is. And the second is synchronous counter or parallel counter. Now this synchronous and asynchronous are again divided further here. Again, asynchronous is divided by binary counter and non-binary counter, and synchronous counter are defined by ring counter, Johnson ring counter, third is random sequence counter. Now the further classification states for this binary as binary can be up counter, up or down counter. Again, this non-binary can be up or down counter. Up can be starting from 0, 1, 2 dash, and down can be 9, 8, 7 and so on. Now let's start with this synchronous counter. What the synchronous counter is? The basic definition of synchronous can be stated that synchronous means the same clock pulse. That is, all the flip-flops having the same clock pulses are called as synchronous counters. An asynchronous counter can be defined as the output of one flip-flop act as an input to other flip-flop. That is what is asynchronous. So I'll show it with the circuit diagram. So that is say output of one flip-flop acts as a input to other. So let's start with this synchronous counter. As seen from the definition, the same clock pulses. So this is the circuit diagram for the same clock pulses. And the asynchronous, that is the output of one flip-flop acts as a clock pulse to the other flip-flop. This is the asynchronous. This is synchronous and this is asynchronous. Now the basic difference between asynchronous and synchronous are like, the most important is the clock pulse. That is the output of one flip-flop acts as a clock pulse, maybe either a positive edge clock pulse or maybe a negative edge clock pulse as per the requirement. The asynchronous clock pulse, asynchronous counter is very slow as compared to synchronous. Plus the asynchronous counter can only count in fixed sequence, that is either increment or decrement. But synchronous counter can count in fixed sequence only. Now let's start up with the binary counters.